happy to announce Arthur Jans, who's gonna give another talk in the web track, I think we can say, about rootkits in web applications, where he's gonna tell us about cross-site scripting, I believe. So the stage is yours.
Thank you. So thank you everyone for coming. I'll just do a short introduction. My name is Arthur Jans and I work at Google, and Google is doing a lot of really serious security research and some not really all that serious research, some sort of wacky stuff. And if you're sort of wondering what the wacky stuff might be, I guess you'll get to see. So I was thinking of this talk as a sort of short, lighthearted overview of some of the issues that are relevant to exploiting web vulnerabilities on web clients. So the first thing to get out of the way is, I know that the talk has rootkits in its title, but it's actually not about rootkits at all. So if you're, if you're used to the idea of rootkits as this thing on the client side that lets you hide processes and enable malware to avoid detection, it's not going to be about that. But it'll be about something that apparently is a little different, but there are many similarities. So what I'm talking about is attacks on web application clients that are due to various kinds of script injection. And obviously the most often discovered attack is cross-site scripting. So I'll do a quick introduction to those attacks and how they work, very quick. And then I'll talk a little bit about the interesting stuff, hopefully for you, which is what happens after a script injection attack actually is successful. So after we have a cross-site scripting victim, what can be done and what are the problems for web application authors related to that. And obviously, for it to be a complete security conference presentation, we have to introduce a new buzzword. There's no other way. So the buzzword for today is resident XSS, and it's sort of tongue-in-cheek, right? I don't think anyone should go off and start using it after I describe it, but it's something that'll help us sort of be on the same page about the particular kind of attack. And then I'll talk a little bit about how, what the difficulties are with cleaning up users who have suffered from this attack. So I mentioned before that this talk isn't really about rootkits, because in traditional software and client-side software, the way you sort of have malware running on users' machines is that first you find a code execution vector, so you find a bug, or you entice a user to click on your executable and fool them that way. If you actually find a vulnerability, you have to bypass ASLR and depth and stuff like that. And after you get to that point, you do the things, as malware, you do the things that I classified loosely as a rootkit, and we can talk about semantics later if anyone wants to. So stuff like inserting a backdoor to maintain access to the machine for an attacker and hiding the presence of attackers' processes on the machine. Let's call that rootkit functionality. And after you have that, after you have the way to execute code and a way to hide your presence and maintain access, then you can do various kinds of evil things, and we've all seen malware and what it does. So this is sort of the traditional way malware has worked, and it never really applied to web apps, right? Because web apps are sort of different. And the sort of idea that I want to impart on you is that web applications have evolved in the last 5 or 10 years to the point where we can have similar things to rootkits running within web applications for a particular user. So, and I'll talk more about that. Unless you've been living under a rock for the last 9 or 10 years, you know what XSS is, but I'll just go over it very quickly. XSS is cross-site scripting. It's when a web application allows external users to submit queries that will execute some code supplied by the attacker in a victim's browser. So for example, if the victim.net domain is not careful about sanitizing or escaping, actually, the user input, the script supplied in the URL parameter will be treated as markup in the user's browser, and it will execute in the context of the victim domain. So the reason for that is that the web application doesn't escape the HTML meta characters, which leads to the vulnerability. Attackers' scripts get to run. There's no way for the browser to distinguish attacker-supplied scripts, in this case, from legitimate scripts on that website. Whatever code the attacker gives to the victim of this attack will be run in the scope of the victim user's authenticated session. The attacker will be able to execute XML HTTP requests back to the same server and basically impersonate the user. It's code execution, sort of, for the web. And whenever people see information about XSS for the first time, they see two things that are my sort of pet peeve, because that's not really how it works. So the first thing you learn about XSS is that you find a vulnerability, you send a link to some user, and they click on it, and then you can run your code. But that isn't really how it works, because you would have to have your entire payload in the URL. There are many other cross-site scripting attacks that wouldn't work this way. The user would see some kind of weird URL with scripts. If you send it to them via email, the link might be broken up onto several lines. Basically, it wouldn't really work. And the second thing is the way you exploit cross-site scripting isn't to just send the cookie, the authentication cookie, back to the attacker. Because one of the first things that we learn about cross-site scripting is that it has access to all the cookies within the victim's browser. So you can just get the browser to send the attacker the session cookie, and the attacker can, from their own machine, send all the requests that are necessary to impersonate the user. So I'm sure a lot of you know, why isn't it how this works? What's the problem with the second thing? Sure.
Most browsers don't allow this. They scan for document cookie in URLs and then they block it.
So browsers don't really allow this, and the reason for this is that document cookie, so there's this attribute set on cookies called HTTP only, which all web apps that know what they're doing are setting on authentication cookies, and which means that JavaScript doesn't have access to authentication cookies. So you can't really steal a cookie this way. There are some vulnerabilities that might let you do that, but really that's not how you would exploit it. So how you could exploit cross-site scripting is to get a user to visit this page with a cute kitten. So obviously there is nothing to let us know that there might be a cross-site scripting exploit there, but there could be invisible frames that do the same thing, basically create an iframe or some other, or a frame to the victim page that the user never sees. Another way to exploit XSS is to just visit any popular internet site. So my claim is that if you visit this page, you might actually fall victim to cross-site scripting in some web application that you're currently logged into. Does anyone have any ideas why that might be?
Yeah, so this,
Oh.
yeah, it's
Ads, exactly, yes. So if you're an attacker, you can just pay an ad network to distribute your flash file or snippet of HTML to be loaded in a frame, and it will be shown on various popular websites. There has actually been research on showing malicious ads to users, or researchers have used this technique to sort of demonstrate distributing evil payloads to users. So this is another way that you could execute XSS. So what would happen is that you, as the user, you visit an attacker's page. There's a hidden frame somewhere there with the cross-site scripting payload, and the exploit runs in the context of the target domain and does something malicious. So the malicious things could be, it could initiate a bank transfer. If you're logged into your banking application, it could transfer money to the attacker. It could set up an email filter for your webmail service that would forward all your incoming emails to the attacker. And it could do a bunch of evil things. Another way is if there's a persistent cross-site scripting bug, which is a way for other users to embed code on a page that you normally see in the web application. Once you fall victim to that, you can. There have been many cases of cross-site scripting worms because of persistent cross-site scripting. But in both cases, and we don't need to get into details about that, but in both cases, the exploit is doing something malicious. But there is a problem from the attacker's point of view, a problem with exploiting this. So once you find a bug and you start exploiting it, and you have to take, so there are two things you have to do. First of all, you know that if you are, if a user visits your page with a picture of a cute kitten, they won't be on that page for very long. And there are some ways in which you can try to get them to stay on that page, but in general, what you would do as an attacker is you would execute your evil code right away as soon as possible. So you just set up your evil email filter or make a bank transfer, and that's it. And the second problem, and the problem associated with that, is that the vulnerable web application immediately sees when users start getting exploited via this technique that there might be maybe 1,000 users or 10,000 users, if we're talking about mass exploitation, that executed some action within a very short period of time. So the web application will know immediately that there is something going on, that there's usually monitoring. So as an attacker, you have to expect that someone will be onto you in maybe minutes, maybe a few hours. And that way you burn your exploit and you can't use it again because supposedly it'll be fixed. So I talked about cross-site scripting a little bit, but it's not really the only way in which you can inject evil scripts onto important domains of applications that internet users use. So cross-site scripting is one of them. There's also universal cross-site scripting, which is when a browser or browser plugin has a bug that affects all web pages. So it's not necessarily that you, as the web application author, have done something wrong. It's possible that there is a bug in a plugin that the user has installed on their machine, and to quote Dan from yesterday, it's always frickin' Java, and it really is, because very recently there have been examples of universal cross-site scripting in the Java plugin that's still very widely installed. Then there are ways to get the user to put a bit of JavaScript in their URL bar, and when you hit enter, it actually executes the code that you put in there. So Facebook has suffered from this attack quite a bit because people were unknowingly pasting snippets of JavaScript into their URL bar, and when you execute it, it actually runs in the context of Facebook without any fault of the web application provider. They didn't do anything wrong, but the users didn't really know what they were doing. It's the same way malware gets distributed when you send someone an evil attachment, when people just don't know any better. And there are some more sophisticated attacks related to abusing the URL bar. And then there are yet other ways of injecting your evil scripts onto target victim domains. So, for example, if the web application is trusting external providers for their JavaScript, for example, the OMG awesome JavaScript bunnies.com, totally trustworthy page, right? I mean, why would we ever worry about their security? But maybe they're not all that awesome, even though they might be bunnies. So they can be compromised, and suddenly the resource that your web application is loading is backdoored in some way and can execute some evil code of the attacker's choosing. And it can also happen to your domain. So if you have a big domain that hosts many applications, it might also host static files that are uploaded by, say, marketing people that have no idea. Is anyone here from a marketing person? All right. So you have clueless marketing people that might have access to a particular directory on your domain, and what if they use the same password on all their web accounts, and the password gets compromised. Someone logs into their account, uploads a file that's an HTML file, can execute scripts. I mean, there are a bunch of attacks like that allow you to inject evil scripts onto some domain. And another sort of good vector that many people don't think about is cache poisoning. So a quick question: who is using the wireless network here? So about half of the people are using the wireless network, and the other half are too lazy to raise their hands, right? So yeah, everyone is using the wireless network here. So when you connect to an untrusted wireless network, you're at the mercy of the provider and other people who might be able to control that network, especially wireless, but not only. So what can happen is that you, after browsing the internet from a network like that, you will continue to use a browser with evil cache, so cached resources that were injected there by the evil network by doing, say, DNS spoofing or just man-in-the-middle on HTTP traffic. And those resources can be very long-lived. So if you can have, for example, a JavaScript snippet that is used in many applications, such as maybe SWF object or one of those popular JavaScript libraries. When you visit, when you browse the web from an untrusted network, it will be backdoored, and by that I mean it might still contain the same functionality that you're expecting. It'll just have an evil script that can be activated in some way by the attacker, and it can live in your browser cache for a year or two. So that's another way. And the last category of things is even for web applications that do HTTPS properly, there are some things that, so if you have a sensitive web application that's only using HTTPS, so it's less vulnerable to the cache poisoning, there are a bunch of bugs that can allow attackers to inject those scripts. So there are mixed content bugs where a web application loads resources over HTTP if the page is HTTPS, which bypasses the HTTPS protections completely. And then we can have stolen or forged certificates, and we can have evil CAs issuing evil certificates, and there's always a chance to get the user to click through a warning, and then they would connect to an attacker's web server that would cache some resource under the context of HTTPS of the victim domain. So I'm going to focus on cross-site scripting, but please take into account that when I say cross-site scripting, it actually all of these possible vectors could be used instead of cross-site scripting. And one other thing to remember is that after an evil script runs in the context of the vulnerable web application, we can assume that the attacker can keep up the communication with the victim's browser. And I'll talk a little more about that. So we talked about ways to inject scripts, but now I'll talk about what bad things attacker-supplied scripts can do in web applications. So now it's time for me to introduce the buzzword of the day, resident XSS. So resident XSS, by my definition, is when malicious code is injected into the user's main web application window or tab. So contrast that with the techniques I mentioned earlier, where there is a hidden frame on some website that might execute the attack. Resident XSS is when the attack, the evil code isn't contained to some hidden frame on some website. It's when the main window that you're interacting with for your, say, social network or webmail client or anything like that, when this window is actually executing the code that the attacker chose. So let me just quickly tell you how that might happen. So if there's persistent cross-site scripting when you use the web application, for example, if there's an email message that someone sent to you that doesn't get escaped properly, you open your webmail application, the code runs, and it runs right in your main web app window. And it could be other things, status updates and comments on a forum, and they would all work that way. It's actually a relatively rare vulnerability these days, compared to all the other kinds of cross-site scripting that are still prevalent on the web. Another way is many new web applications use client-side storage mechanisms introduced in HTML5. So local storage or web SQL, web database functionality, which lets them store large amounts of data in the browser. But the problem is that when there is a cross-site scripting bug, the attacker can quickly backdoor the data in the victim's browser, and for example, when the cached JavaScript file gets loaded, next time the user logs into the application, it will also contain the attacker-supplied code. And there was a great paper investigating that by Dawn Song and the students at her lab at UC Berkeley. I think it's called The Emperor's New API, so it's definitely worth a read. And they found that a lot of the new sort of cool web applications are using those techniques and are indeed vulnerable. And then there are other ways. For example, if you have a regular cross-site scripting bug, it can open a new window to the main application. So, for example, if you fall victim to that attack, you would see two webmail windows right next to one another, and one of them is the one that you opened, and the second one is one that was opened by an evil hidden frame somewhere, and that frame managed to open that window and inject attacker's code into that. So that's another technique. And there are a bunch of other ways. So my main point here is that any script injection vulnerability can be, with a high degree of success, converted into a resident XSS. So I've talked quite a bit about all of that, but now let's get to the actually interesting part of the talk, which is once you run resident XSS in someone's browser, all the assumptions they have about interacting with the web application are violated. So let me tell you what I mean by that. So first of all, once you have this web application that runs attacker's JavaScript, you say you want to log out because maybe there's something strange. You think maybe there was an attack on your browser, or you just want to close it. So the first thing you do is you click log off. But, well, the web application is now running the injected JavaScript, so the attacker can hijack the log out button. And so that when you click it, it actually, so in the sort of basic case, it might not do anything, so you can't really log off. And the attacker could also do more sneaky things. For example, when you click on log out, it could create a small window in the background to bypass pop-up blockers, then close the web application window, but keep its own session running in the window in the background. So basically, and another thing that it could do is, say, for your banking application, which times out after a few minutes or half an hour or something like that. The attacker, when you click log off, the attacker could show you the logout page, so saying, thank you, you have logged out, everything is peachy, and then continue issuing keep alive requests to the banking application server, so that you think you're logged out, you got the page that says you're logged out, but it actually keeps polling the server and keeps the session alive until you close that tab. But when that happens, the attacker has yet other ways to keep the infected session going. Another thing is you can't really leave that web application that's been infected. So if you have a link and you want to follow it and you expect the link to take you to another page, the attacker can just open it in another window. You can basically any kind of navigation that you expect the web application to do can be subverted. But those are just things to keep you in the attacker's hands. But the interesting thing is what the attacker can do once you're interacting with the web application. So, for example, off-the-record chats or any keystrokes that are typed into that application can be monitored by the attacker because he is running his evil scripts there. Mouse movements or any other thing basically can be monitored that you're doing, even if there is no functionality to sort of save it to the web application, just because it's in the browser's DOM when you're interacting with it, the attacker can get to it. And the attacker can also modify anything. So you can see messages in your webmail that come from the attacker that are indistinguishable from valid messages. And there's no trace of that at all. So for example, if you get scammed, you get the police to issue a subpoena against the web application, the webmail provider to try and track down the scammers, they won't see anything in their logs because it's not really it's not a real mail message that you got. It's a spoofed one. And there are a bunch of other things. So once you're in that application, the attacker can show a fake login page to pretend that you're logged out. You will type in your password, maybe your one-time password or SMS code, and the attacker can get that data. And then after you do that, the overlay can just disappear, and you see you're logged into the web application again. And you just don't suspect anything, because why would you? It can fish for security questions. So, and that's even sneakier, because it lets you attack other web applications using the knowledge that you get from hijacking just one of the web applications that the user is using. And then there are things like geolocation APIs or a microphone or a camera that you might have granted access to just that application, but the way the browser keeps track of which applications can access those features is by origins. So the attacker scripts run in the vulnerable origin. And if there are if there's any functionality like file downloads, so you're in your webmail application, you click on the attachment to download that. you think you're downloading just an attachment that you got from someone, but it's actually an attacker's executable. So you can just open malicious file download dialogues, and the user might think it's a trusted bit of code from the application. And the same thing with malicious plugins. So the attacker can prevent you from using the application at all until you install the plugin of their choice. So, given the choice of installing the plugin that you don't really know is evil and just abandoning the web application, most people are probably inclined to just install it. And there are a few other things as well. So, for example, if you're in your webmail application and you get a link to CNN.com, what the attacker can do is open the CNN.com page in another tab and inject its own JavaScript into that page. So obviously, if there are no cross-site scripting bugs on CNN, the attacker can't do it directly. But if there are any ads on CNN, the attacker can navigate the frames. So the same origin policy has some exceptions for what kinds of cross-origin navigation can be done. And even if you can't access a page directly, you can navigate its frames to see if there is a frame that you can control, at which point the attacker can inject his code into that frame. So, and once you have all that, once you have the long-term access to the victim's browser, you can do, so other than monitoring all the data in the web application itself, you can do other malicious JavaScript tricks. So you have a lot of time to do history detection, scan local networks, possibly attack other web applications, and distributed denial of service, all of that. And it really doesn't show up anywhere because the web application doesn't really see that there's anything wrong. You don't see that there's anything wrong. It's just injected code into the web app. So yeah, it's not good, right? I mean, once you fall victim to that, it's all bets are off. We're sort of doomed. But let's say that the resident XSS didn't really work. So you got to run cross-site scripting for a few seconds, then the user just closed the tab altogether, or you weren't able to achieve the resident XSS. There are things you can do to maintain access to the user's web application session regardless. So for example, you can backdoor HTML5 local storage and various kinds of web databases. You can backdoor Flash cookies. So if the Flash local shared object data stores some kinds of configuration files or executable data, you can inject attacker code into there. So next time the user loads up the web application legitimately, they will execute your code again. And if there are any cross-site scripting bugs based on cookies, you can exploit that. But there are also some new mechanisms that are being developed in HTML5 that make these kinds of attacks easier. So I don't mean to bash HTML5 because in many ways it's great and it's awesome, but it gives attackers the same features that it gives legitimate web developers. So it actually makes some things easier for attackers as well. But even without all those cool HTML5 tricks, there are ways to keep the attacker code running in the victim's browser. So opening up new windows that won't be visible to the user in the background, that will point to the victim's domain. So for example, you would have your social network tab And if you close that, the attacker can create a pop-under window, and before you manage to stop all the attacker's scripts, they can be injected back into that tiny window in the background. So even though you think you've closed all the tabs that might have attacker-supplied code, you can have windows or frames on completely unrelated websites where this code was injected that still keeps running in the context of your domain. And the name for that is frame hopping, where you keep injecting this code wherever you can. So when the user closes one tab, the attacker can look at all the other tabs that it has access to and either exploit cross-site scripting bugs in them, which is much harder, or just look for frames to add domains where everyone can inject their own code and survive this way. So after an attack like that executes, there is relatively little that the web application itself can do to eliminate the attacker's access to itself. Because if you keep a tab open to your social network, to a page from the social network's domain that had the cross-site scripting code, the evil code running, it will always have access to other pages within the same domain. So when you might log out of your social network in another tab, but whenever you log in again, that evil tab has access to all your data again. So, and there is no way as the web application developer that you can close this tab in the user's browser. So it's been sort of permanently scarred by the code that the attacker chose. And it always has access to your web application session. And you might think that if you add some functionality so that every page on your domain will poll your server for some cleanup code that you might want to run. So every 5 minutes, you will get some JavaScript from the server and execute it. And if the code sees that there's something wrong with the page, it'll close it, just as sort of a precaution. That obviously doesn't work because the attacker can always just disable that code because he is running JavaScript on that page. And you can't really even tell the user that there is something wrong or that they should close the browser and use a different browser profile or clean everything up, because the attacker has control over everything that you might send to the user in some cases. So you can't just say, fix everything to the user, because the attacker can intercept this message and just hide it. So as the user, if you think you've been attacked this way, what can you do? So let's think of some things that might work. So first of all, what if we just close the tab with the web application? Well, that doesn't really help, because there might be other tabs or other hidden frames that are still running the injected code. If you first close all the tabs and then just close the browser completely, so that there's no runtime that is maintained across the browser closure, the problem is that you might have the client-side storage, the HTML5 local storage mechanism, or cache that has been manipulated by the attacker. So next time you open up the browser, even if you have no tabs, the first time you navigate to the web application, it will get rehacked because of the poisoned client-side storage. And so you might think, okay, let's clear all the local storage, then we'll restart the browser and everything will be okay. But between the time that you clean up all the local storage and you close the browser, any tab that is open that is controlled by the attacker can actually re-poison all the client-side storage, because there's a small time delay between cleaning everything up and closing the browser. So sorry. Wow. Okay. So there is something that actually might let you clean up your browser profile after you've been attacked this way. So you close all windows, you close all tabs, you keep one tab open, you navigate it to a safe origin that no attacker scripts should have access to. You remove everything, you restart the browser, you hope that the vulnerability was fixed and that there are no self-XSS bugs that might have been exploited in the meantime by the attacker. But I mean, try explaining that to your mom or just a casual internet user. It's a really complex process. So in a way, just throwing away the browser profile after you've been victim to cross-site scripting in one web application might be the easiest thing to do, which is sort of scary, right? Because think of all the data that you have in your browser profile. You have history, you have cache and cookies and all of that, and just to throw everything away because of one web application that was attacked, that sort of it boggles the mind. But unfortunately, I mean that might be the most sensible thing to do. So just to sort of recap and finally talk a little bit about rootkits. So those are the analogies that I came up with between the traditional client-side bugs and web application bugs. So code execution or remote code execution is in a way, cross-site scripting is the analog to that. And the same way your exploit has to worry about mitigations on the client side, you have to worry about cross-site scripting filters or web application firewalls that might not allow you to exploit the bug that you want to exploit. And for maintaining access, the poison local storage or frame hopping are techniques that you can use in web browsers. And one thing that is quite interesting that I haven't really talked about is for most malware, you have some command and control channel to back to the attacker. And obviously, in the web application, you can just keep loading a script from the attacker's domain and get commands this way. But there are so many stealthy ways to sneak in code that would look completely innocuous to someone just running a sniffer. So you could have DNS-based covert channels. You can have there's this thing in HTML5 called web workers. You can create an invisible window in a way, or invisible JavaScript execution context that will keep asking the attacker's server for a JavaScript file to execute that you will never see in Firebug or in your web inspector in Chrome and communicate with the infected page with post message. There are whole numbers of ways of doing that. And the malicious payloads, similar to the client side, just running a keylogger or doing denial of service attacks. In web applications, you can also compromise the data in the web application, try and elevate access to other applications, and do the usual malicious JavaScript tricks that I talked about. So this is almost the end. So the thing I want to leave you with today is there are two thoughts, basically. So the first one is that after you or your users have been victim to a cross-site scripting or a script injection attack, it's really, really hard to reliably clean this up and to make sure that any future interactions of the user with your web application will have integrity in any sense of the word, because you can always have attacker-supplied scripts hiding somewhere in the browser that you're just not aware of and you can't get rid of. And the second thing is, and it's something that we haven't seen yet, but maybe, I would be very happy if we didn't see it at all. But the sort of attacks that are enabled by the resident cross-site scripting class of bugs are quite nasty because of all the assumptions that they violate in users' minds. So you just don't realize that the application you're using might do all the things to harm you. So, snooping on you, phishing you, and just act against your interest. Because we're not really used to that, right? On the client side, if you have injected code, it doesn't really inject itself into existing applications most of the time. So if you have a backdoored version of Microsoft Office, it doesn't really intercept your click on the file menu, because why would it? And things like that are possible and are actually remarkably easy to do with JavaScript in web browsers. I just want to thank two of my colleagues who really helped flesh out the ideas that I talked about today. Michał Zalewski is a great web security guy and security guy in general. He recently wrote a book called The Tangled Web, and if you have any interest in web security, this is the book to read. So I strongly encourage you read it. Just a word of caution: if you search for it on Amazon, there are some other books by the same title. His one doesn't have the naked guy on the cover. So just search for that one. And Eduardo Villanova is another one of my colleagues who is amazing at all client-side things, and he helped me out a lot as well. Thank you very much.
Thank you very much, Arthur, for that great talk. Let me just reiterate what I said at the beginning. If you would, we're going to have a Q&A session now, so if you would be so kind to maybe stay seated and quiet until we're done so everyone can enjoy it, and take all your trash with you when you leave later and leave via the front door. But let's start with some questions. Okay, well. Right, let's just wait half a minute for the impatient. Okay, let's start with a question from the front row.
So I noticed you haven't actually covered anything about like attacking browser plugins or like add-ons or like stuff like that, because like there's been hilarious bugs and stuff like TweetDeck and whatever else, and like in Chrome. So there's like permissions, so they're somewhat restricted, but like obviously because they are going to use local storage, I mean, wouldn't that be a better target? I'm just surprised you didn't cover anything on them.
So this is actually a very good point. So most of the plugins that or the add-ons that use local storage do it in the context of the in the origin of their sort of web application, right? So you have, or often they trust that data. So by running cross-site scripting in the context of that origin, you can actually elevate privileges because the add-on will treat that data as trusted, because why wouldn't it? It's their domain. And yes, so it would give you privilege escalation because you would execute in the context of the add-on rather than just a random web app. Yeah, thanks.
Right. Further questions? Yeah.
Do you have any knowledge about known exploits of this concept in the wild?
Not really. So I believe right now it's actually easier to get users to run malicious executables in many ways, unfortunately. So there are so many easier things to do than doing all the work to backdoor someone's web application session if you can just get them to double click on an exe. But I do think I'm a little afraid that something like this will come to the web world once the sort of low-hanging fruit attacks are harder than they are right now. So just the question is, will they ever get difficult enough that it'll be worthwhile for attackers to use these techniques?
Hi. Hi. Hello. I have two questions just for understanding this better. The first is I have the scenario now. I go to a website, I get this malicious code somewhere in my local storage. I close my browser, it's there in the local storage. Now the website detects the malicious code, removes the malicious code, and now I go back to the website. So what is the help in the local storage? I mean, it's not evolved the local storage. What does the attacker get from my local storage when it's still there?
So the main problem is that that a lot of web applications trust the data in local storage, right? So they just eval a JavaScript resource that's in there. So once the web application cleans it up.
Okay, so you mean the local storage is evolved sometimes from the website by intention?
Yes. So we can treat it as a bug. And the paper I mentioned, the Emperor's new APIs, they were actually they got in touch with a lot of web application providers, telling them, maybe you shouldn't be trusting the data in local storage because it can have negative consequences. For example, secondary cross-site scripting.
Okay, so then everything is clear. I didn't know the fact that websites really eval the local storage.
So it doesn't have to be evaled, right? So there are many other ways.
But otherwise, so you gain no advantage, I think.
There are other ways in which they trust the data that doesn't have to resort to eval. For example, if you use it in an inner HTML assignment, if you store some snippets of sanitized HTML, you sanitize it on the server side, your application puts it in local storage, then you trust it. Then when you use it again, the attacker code can be injected.
Okay.
Right. We then have a question from the interwebs.
Hello. One question from Brussels. He asks, what can a sysadmin do to prepare for this?
That's a tough one. So I hate to say nothing, but really nothing. My main worry is that there's relatively little that web applications themselves can do about it, right? So even at that level, for just the local storage attacks, you can make sure you never trust anything in local storage, or you can have signatures on any data that you want to eval or something like that. But for sysadmins, I don't really see any mitigations.
Okay, another one?
Another one. Quick question. What about the privacy modes of web browsers? Do they mitigate the problem of recovering from once it has been infected?
Yes. So this is a very good point that I didn't mention. So if you run in private browsing mode for pretty much all your web navigation, this will help, right? Because there will be no. So once you close it, all the local storage data gets wiped out. The execution contexts of all the code that might be running in hidden windows or tabs or hidden frames will also get wiped out. So the only problem I see with that is if Flash doesn't play well, and I know historically there are some incompatibilities between Flash shared objects and browser's private modes. You could potentially inject some data into Flash cookies that would persist after you quit the private browsing mode. But yes, this is a good mitigation. But then you sort of, so I actually think it's a very good solution, but when you do that, you lose on some of the benefits of using a modern browser. You don't have any history, any saved data, but might be a worthwhile trade-off.
wouldn't it be possible to use some kind of hashing like Git does for the local storage? Maybe an external program to check it up before the browser starts or anything like this?
So you could, as a web application, if you intend to eval a blob of JavaScript when you start your application, you can definitely you can have a signature-based system to verify the integrity of that. The problem is that you can't really store the signature anywhere on the client side because that can be tampered with. But if you always get the signature from the server, you run some kind of you run RSA on it, you verify that the local storage is correct, and then you load it. It might have some problems. For example, if between the time you run the check and the time you actually load it, if it has been tampered with, then you would still, there are race conditions there. But in general, it's probably if you use local storage cache, which is actually a recommended solution for mobile apps. So we have a lot of the people in the web performance community pushing for using the client-side storage mechanisms as cache for CSS and JavaScript and other kinds of resources. So I actually think some kind of signature system would be a good way to make sure that you can use this mechanism safely. Okay, thanks.
Okay, there's time for one or two more. No further questions? All right. Then let's thank Arthur again for the great talk.